So this is on page 5, right, of 9.6. We're going to do number 8 because we've already done number 7. It says solve the right triangle. What is it asking for when it says solve the right triangle? The whole thing. The missing angles, missing sides. So what do we want to solve for first?
The missing side.
Sure. Yeah, this sounds good. We can solve for ED. I know 2 sides. How do I find my third side? Pythagorean theorem. So we'll start there. A squared plus B squared equals C squared. Which letter is missing, A, B, or C?
B.
B. Sounds good. So 21 squared and x squared, because 75 is across from our hypotenuse. So it's across from the right angle, I mean. So it's the hypotenuse. 21 squared is good, plus x squared. And then what's 75 squared? 5,625. Subtract 441. Good. 5,184. And then take the square root. 72. So make sure you don't call it x equals. You call it ED is, the length of ED. So we found all the sides. We can find the angles. Which angle would you like to solve for first? C sounds good. From C, what kind of side is 21? Adjacent. What kind of side is 75? Hypotenuse. So which trig ratio will we use?
Cosine.
Cosine. From C equals the adjacent. So 21 over the hypotenuse, 75. We're solving for an angle. How do I get rid of cosine? Shift. I'm going to use the inverse. So inverse of cosine of 21 over 75. So what do we get for the measure of angle C?
73.73.
Do we all agree? Did anybody else type it in? Okay. All right, and then for angle D, what kind of side is 21? And then is the hypotenuse going to change? No. So which trig ratio would we use there? Sine. From angle D equals the opposite, so 21 over the hypotenuse, 75. We're solving for an angle. Anytime you solve for an angle, you're going to hit shift sine. So what do we get for the measure of angle D? 16.3, right? Yeah, degrees. So you have a quiz on Friday. I think it's 10 questions. One of them looks like each of these. So make sure you're able to solve the one on the left as well as solve on the right. We're going to go ahead and finish the word problem notes. Oops, go back. So go ahead and go to page 3 of your word problems. Because once you know how to set up a word problem, you obviously need to know how to solve that word problem. So let's talk about methods we would use. So the first one, it says solve for the side. Can I use the Pythagorean theorem? No. I have to use a trig ratio. Which trig ratio would I use? What did you say? Sine. Correct. Because x is opposite and 5 is the hypotenuse. So sine from 23 would equal the opposite over the hypotenuse. Would I need to flip this one? No. Just multiply times 5. We can round to the 10th. So what would we get here? 2. Yeah. The second one, we can just talk about how you would set it up. We don't have to solve for it. You want to solve for a side. You have 6 and 2.1. So what would we use to solve for that last side? Pythagorean theorem. So we'll write it down and show how we would plug in, and then we can stop there. Which letter is missing, A, B, or C? Sounds good. So what is A going to be? 2.1 squared plus we don't know squared equals 6 squared, because this would be your hypotenuse. We don't have to keep solving. I feel like we know how to do the Pythagorean theorem. The last one says solve for the angle of elevation. Can I use the Pythagorean theorem to solve for an angle? No. I got to use trig ratio. Which angle is the angle of elevation?
The bottom, right?
The bottom right. So if you can't use the Pythagorean theorem, you're going to use a trig ratio. What kind of side is 9? And then 8.4 is, so which trig ratio is that? Tangent. We will solve for this one just to practice. But tangent from x, or whatever you called it, equals 9 over 8.4. To get rid of tangent, you have to use the inverse. So you're going to hit shift tangent of 9 over 8.4. We can round to the 10th like normal. What do we get?
47
Degrees. Beautiful. Perfect. All right, so the last thing we're going to do is this problem. It's a harder problem. I would say the bonus on Friday's quiz looks similar to this. We're going to read it and draw a picture. It is on the last page of the notes. You're flying a kite with 20 feet of string extended. The angle of elevation from the spool of string to the kite is 67 degrees. So we're going to draw a picture. So we're going to be standing on the ground, right? I would hope so. And then draw you. All right. You're flying a kite. So where do flights usually kite? Do they fly? Where do they kite? Do they fly right above you?
No, they fly
They fly out at an angle. So just put a kite somewhere. And then the string is attached to a spool. Where is the spool? Is it on the ground?
It's in your hand.
It's in your hand. So hopefully we're all tracking. I made my spool orange so you can see. So let's go back. It says you are flying a kite with 20 feet of string extended. So my string is 20 feet long. My angle of elevation, so we're going to have to make an angle of elevation, from the spool to the kite is 67. So an angle of elevation, what will one of the sides of an angle of elevation always look like? So here's an angle of elevation. What will one of the sides always be?
Inside the time.
Nope.
What was the question?
For an angle of elevation, what will one of the sides of the angle always be? They'll be horizontal. So an angle of elevation starts at a horizontal line and goes up. Angle of depression, horizontal line goes downward. So from the spool, there should be a horizontal line. Hopefully yours look better than mine. And the angle going up towards the kite, so from the spool to the kite, is 67 degrees. So draw and label a diagram. So we did that. How far off the ground is the kite if you hold the spool 5 feet off the ground? So an important piece is that the spool is 5 feet off the ground. So we got to keep that in mind later on. But it says, how high is the kite? So that's a height. What part of the triangle will that be? The vertical side, right? So we want to find the height. However, the height, if you look at this, our triangle starts at the spool. Does everyone see it? It does not start on the ground. So what we're going to do is solve for the height of our triangle, but then we will have to eventually account for the last 5 feet. So what will we do with that 5 feet at the end? We're going to add it in. So we're going to find the height from the spool to the kite, and then we'll add in the remainder. So I have an angle, which is 67 degrees. So we're looking at this triangle. All right, we have 67 degrees. We want to find the height. What kind of side is the height? Opposite. And then what kind of side is 20 degrees? It's the hypotenuse. It's because a horizontal line meeting a vertical line, we measure height vertically, and then your angle of elevation will always be a horizontal line. That's where your right angle is, if you wondered. But which trig ratio am I going to use? Sine from 67. It'll equal the opposite, we don't know, over the hypotenuse 20. Do I need to flip this one?
No.
I do not. So what is the height from the spool to the kite? 18.4 feet. So that's not the whole height. That's only from the spool to the kite. So to find the total height, we're going to have to add in that 5 feet. So go ahead and add 5. What is 18.4 plus 5?
23.4.
Good. And then you'd say feet.
Yes, Martha, you put 5 twice.
I just wrote it in a different place. He asked why I wrote 5 twice. I just wanted to show you that if it's 5 feet here, then it'll be 5 feet over there too. Describe how the height where you hold the spool affects the height of the kite. Obviously, the higher you hold the spool, the higher the kite's going to be, right? This is probably a tall person because 5 feet is pretty tall. Like I'm 5'3". That would, if I were standing, it, which is weird. So, anyways, you'll see a question like this as a bonus. So, what you're going to do is take out a whiteboard and a marker. We're going to have you practice So you're going to draw the picture. If you want me to check the picture, you're more than welcome to. Now you can solve. Yep, you can show me and then you can solve. Make sure you put X somewhere. So you can draw a picture, make sure you put X. Now you can solve.
Oh, it said width, and I was like, well, that's the height.
It doesn't necessarily matter. Yes, ma'am. You can solve. You flashed it? I didn't see it. I saw his. You're also pointing at the other direction. Okay, that's better. That's good. Isabel, I just need to see yours. Yep. Yep. So you drew a right triangle. The one that matters is the diagonal. It's 25 inches. That's the hypotenuse. The other ones, it doesn't matter which one you call length and width. It's the same thing. So if you said 20 and then X, or X and 20, it's the same. You're going to get the same answer. Correct. Correct. Yes, ma'am. So you're not solving for an angle, you're not going to use cosine. You're going to solve for a side. Correct. Correct. So how do I solve for a side if I know, correct, if I know two sides and I want to find the third? Pythagorean theorem. Which of these is C? 25. The other ones are interchangeable, but you should end up with x equals 15 inches. Right? Which is why a TV is measured by the diagonal. It sounds a lot better for it to be a 25-inch TV than a 20-inch TV. The next one you're going to draw. A damsel is in distress and being held captive in a tower. Her knight in shining armor is on the ground below with a ladder. When the knight stands 15 feet from the base of the tower and looks up at his precious damsel, the angle of elevation to her window is 60 degrees. How long does the ladder have to be?
What is a damsel?
It's
Like
a lady. Well, in distress means she's in trouble. A damsel is just a unmarried young lady.
I thought it was a widow.
A
No.
widow's like if your husband's in that.
Man, you write really small.
I don't know.
Okay, that's good. That's good. Not quite. Not quite. Mm-mm. I don't know where your X is. That's good. No, that was right, Kobe.
It was?
That was a person, right?
Mm-hmm.
Mm-hmm, that's right. Your picture's wrong. So as damsel is being held captive in a tower. So what's my tower going to be in this picture?
It's gonna be an angle of depression.
Elevation.
Well, I just meant which side.
Oh.
You can envision it as like, here's a tower, and here's the lady. She seems like a Rapunzel, so there's her hair. He's standing on the ground below with a ladder. He stands 15 feet from the base of the tower. Here's the base of the tower. He's standing 15 feet away. So remember when I said from, it's going to be down here, because he's going to be standing over here. And looks up at his precious damsel with an angle of elevation. Look at your notes. Which angle is the angle of elevation? That bottom right one. And then it says, how long does the ladder have to be? Which side will always be the ladder? The hypotenuse. So you're trying to, oh, sorry. I put X here. The angle of elevation is 60. This is what your picture should look like. Go ahead and take a second to solve it. Are you going to use the Pythagorean theorem or a trig ratio? Which one are you going to use? Cosine. What will go in the numerator? 15 and then x. Do I need to flip it? I do. Oops. Multiply by 15 and what do we get? 30 feet. This is the last one. We can call this first one Part A and Part B. You can use the same picture. The bottom of the ladder must be placed 3 feet from a wall. The ladder is 12 feet long. Part A says how far above the ground does the ladder touch the wall. Part B says what is the angle made between the ladder and the wall. So you need to figure out where a ladder is. I would memorize that. Is that for the first one? You marked an angle. The first one's asking how far. I think correct, yes. That's the second one, yeah.
Must be wrong.
That's good. And then now for A, where would your X go?
Oh. Right.
That's the first one, yeah. That's an angle, right? Did it ask for an angle? Good. Look at where your ladder's going to be on that paper. The ladder will always be a certain side. First one's right, second one's not. How's your picture going back there, Trey? What's the hypotenuse? Oh, sorry. What's the ladder always going to be? The hypotenuse. And it's 12 feet, right? Then it says you place 3 feet from a wall. So what's that going to be? The bottom. How far above? So far, is that an angle? That's a length. How far above the ground does the ladder touch the wall? Which of these sides represents the wall?
Vertical.
The vertical. Which of them represents the ground?
3.
Yeah, the bottom, right? So how far does the ladder, which is up here, touch the wall? So you're looking for a height there. So how do you find a missing side if you know 3 and 12?
Oh, it's
The Pythagorean theorem. So you would do x squared plus 3 squared equals 12 squared. You get 11.6 feet. The second one, you want to find the angle made between the ladder and the wall. So which angle is between the ladder and the wall?
the angle of depression.
That is not the angle of depression.
Like,
No.
Is the angle on the top?
So here's my ladder, and here's my wall. So this is the angle you're looking for. The angle of depression is not inside of a triangle, it's on the outside. So which trig ratio would you use?
Cosine.
Or sine.
You'd use sine.
Oh, I didn't know we had to use the 3. I thought we had to use
Oh, you used the other one? Did you get the right answer? What'd you get?
14.8.
Yeah, no, it's 14 and a half.
Oh. Because I did,
I know.
cosine.
We just used like what was given us because you rounded to 11.6, so it's not the absolute correct answer. All right, you're gonna take out a scrap sheet of paper. We're gonna go to IXL. We're gonna have you practice